Okay. You guys are going to have a test on Friday. I think I should have your study guide for you tomorrow. And I think you'll have a work day. Tomorrow we'll finish up 2-9. Today we start. Tomorrow we finish up 2-9. And on Wednesday, I think you'll have a full work day. And then Thursday will be your study guide day and Friday test. So I think that that's kind of our schedule. How does that sound? Okay, so let's get started on new content today. We start out with the definition of one-to-one. Anybody remember what a definition of a function is? A relation in which every element of the domain corresponds to exactly one element of the range. So, a function is said to be one-to-one if every element of the domain corresponds to exactly one element in the range that actually just made it a function. We say it's one-to-one if the converse is true. And every element in the range corresponds to exactly one element in the domain. Let you finish writing that down. So the first way is just the definition of a function. And then the second part is just the inverse. Or I'm sorry, the converse. Which is, maybe it's not even said as the converse. But the point is that if it's in the, for every element in the range corresponds exactly one in the domain. So I'm going to draw two functions up on the board. Everybody agree that's a function? How do you know for sure that's a function? Passes the vertical line test. And draw another one. Is that a function as well? Yes. One of these is one-to-one. One of these is not one-to-one. Anybody want to take a guess? Remember that the definition says every element in the range corresponds to exactly one element in the domain. So watch what happens if I consider, let's say, the value of positive 1. So right here has a range value of positive 1, and positive 1. So you can see that a range value of positive 1 for the red function has 3 different domain values. x1, x2, x3. That's a problem, isn't it? If you're going to be one-to-one, your output can only correspond to one input. But an output of 1 corresponds to 3 inputs. So therefore, the red function is not one-to-one. But the green function is. In order for a function to be one-to-one, it must pass the vertical line test. And that's just to test whether or not it's a function. And the what? Horizontal. Can you see that the green one passes the horizontal line test, whereas the red one does not? Therefore, we know right away that it's not one-to-one. Okay. So, that's all I have for you about one-to-one. Any questions on one-to-one? Can you memorize that definition for the test? You're able to memorize a function. Now you just got to switch the last part. That's all you got to do. You ready for that? If functions are one-to-one, it's easy to find their inverses. What are function inverses? Function inverses are this. Okay? F inverse of x is an inverse of f of x. There's three things I want to write down here. That's the first thing. Second thing I want you to understand is this. F inverse of x is not the same thing as 1 over f of x. Those are entirely different. So after a while, we run out of certain terminology in mathematics that kind of works out for our likings. So that's not true. Are we okay with that? Okay, last thing is this. If f of x is equal to y, then f inverse of y is equal to x. Here's what happens. For inverses, we switch the x and the y values. So let's say that your domain was for f of x. That becomes your range for f inverse of x. Watch this example. Let's suppose that f of x is y equals 2x plus 3. F inverse says that we switch the x and the y values. So if you want to find the inverse of a function, we switch the domain and the range around. And so instead of writing y equals 2x plus 3, I'm going to write x equals 2y plus 3. And then I solve for y. How do you solve for y in this problem? Minus 3. So you got x minus 3 is equal to 2y. Now what? Divide by 2. And you get y is equal to x minus 3 over 2. Those two are inverses of one another. Take out your graphing calculators and I'll show you why. Okay, I want you to take, and for the first one, plug in y equals 2x plus 3. So 2x plus 3. And then for the second one, let's go x minus 3 divided by 2. You could write that as 1/2 x minus 3 halves. That would be fine. I'm going to punch it in, though, as x minus 3 divided by 2. Everybody got it? Okay, now I'm going to do something a little bit different. I'm going to go zoom decimal 4. And now I want you to press trace. what the zoom decimal does is it counts each pixel as a tenth. Okay, so this is just going to be helpful for us here in a second. So I want you to look at something though, okay? Anna, you got a question? So look at this point, 0, 3. Everybody see that this line passes through 0, 3? Look at its inverse. For its inverse, the x and the y values switch. So if you switch the x and the y values here, what do you come up with? 3, 0, right? Well, if you look at this function right here, you can see as we scroll over that it passes through the point. As we get there, there we go, 3, 0. Choose any point on this one. Choose any point at all. Let's look at this. 2.1 and negative 0.45. Okay? That's a picture. Here. 2 and negative 0.5. Okay, 2 and negative 0.5. That means that its inverse, the other function, will go through negative 0.5 and positive 2. They just switch values. So if I do that, if I go over here, negative 0.5, negative 0.5, positive 2. They're mirror images of one another, switching the x and y values. That's all that happens. So they exchange those values. And here's the other piece. Let's go back into y equals. And for your third one, type in x. And let's make it bold so that it stands out. And then let's zoom in a standard viewing window. Let's go zoom 6. So there's my first one. There's the inverse, and there's the line y equals x. Look at that. The one line is reflected over that line y equals x. See that? It goes right down the middle. If you were to take the function and flip it over the line y equals x, you would get the other function. So that's another piece about inverses. Graphically, inverses are reflected over the line y equals x. So, a couple questions, see if we get it, okay? First of all, inverses switch what? What do they switch? The x and y, or the, what's another name for x and y? Domain and range. So that's what inverses do. They flip those values. Second of all, in order to test to see if a function is one-to-one, you use the horizontal line test, okay? Third of all, if you want to test to see, or let's say we want to actually find the inverse, as Alex said, we switch the x and y values. If we want to test, so this is the third thing, if you want to test to see if something's an inverse, here's what you need to do. F of f inverse of x is equal to x, and f inverse of f of x is equal to x. Anybody remember what those are called? When we put two functions together like that, one inside another? Starts with a C. Composition. This is a composition of functions. We did that before break. And if you take the two functions, you compose them of each other, you should get x. And you have to test it both ways. So let's take these two that I did here, and let's make sure that they are, in fact, inverses of each other. Okay? So the first thing I'm going to do is I'm going to do f of f inverse of x. So what do I plug in for x if I want to test this? What do I plug in for x? I take this, and I put it there. And when I do, I should come out with x. So I'm going to try that. I'm going to go 2 times x minus 3 over 2 plus 3. So I'm doing my composition of the function and the inverse, and I'm going to see what I get. Now, what does this simplify to? 2 times x minus 3 over 2. What does that simplify to? The 2 times the 2 over the 2 cancel, right? And I get x minus 3 plus 3. What happens to the minus 3 and the plus 3? They go away and you're left with x. So we tested it one way and we got out x. So that's good news. Let's test it another way. Okay? Let's plug in. Now we have to do f inverse of f of x. So what I need to do now is I need to take this f of x and plug it into here. If I do that, I get 2x plus 3 minus 3 all over 2. Any questions where I came up with that value? Okay, so if you simplify this, you have 3 minus 3 is 0. So I get 2x over 2, which is x. So you can see in both situations I arrive at x. So because I've tested it for both, we have verified that those are in fact inverses of each other. We've done our work. Now, the next 2 pieces that we are going to do is just practicing this type of thought. But this is all the extent of the knowledge really that we need to have in order to do this stuff. So once you guys have this, we'll be good to go. So let's practice some of the basic problems. Example 1, this will be the first stuff you have on your assignment. It said f of 2 is 3, f of 1 is 9, f of negative 3 is 8, and f of 4 is 5. And f is 1 to 1, so find the following. This says f inverse of 8 is equal to something. What that means is f of what gives you 8? F of what gives me 8? Yeah, f of negative 3 gives me 8. So f inverse of 8 is negative 3. Normally we say, give me an input and I'll give you an output. Inverses say, given the output, tell me what the input was. So if the function has an output of 3, what input gives you an output of 3? Two is the input that gives you an output of 3. What is the input that gives you an output of 5? 4. And what is the input that gives you an output of 9? So if you have a problem like that, could you do that? What if your book said this? What if your book said f of x is equal to x minus 5? And your book said find f inverse of 10. That's saying what input would give you an output of 10, right? So what input gives me an output of 10? 15. No problems. So that's the first type of example you're going to be asked to do. Okay, find inverses given values. Now it says find inverses of the functions. So we said in order to find the inverse, you switch what? The x and the y values. So instead of y equals 2x minus 5, I have x equals 2y minus 5. How do I solve that? What should I do? Add 5 and divide by 2. So x plus 5 is equal to 2y. Divide by 2. Y equals x plus 5 divided by 2. If you want to write it as 1/2 x plus 5 over 2, that would be fine as well. That's my function. That's my inverse. So you could, this would be probably the more formal way of writing it. F inverse of x is equal to x plus 5 divided by 2. Any questions? That one's easy, right? Let's try some that are more difficult. We're going to do 3 more, and then I can give you your assignment. But these are a little bit more challenging. So we have y is 2 minus x over 3x minus 4. If you want to find the inverse, you switch the x and the y values. So I'm going to write a new one. I'm going to say x is equal to 2 minus y over 3y minus 4. Now, I had you guys do this back on your first test. You're asked to solve for y. Some of you guys did very well with it. Some of you guys didn't do as well. So you get practice with it again. First, I'm just going to cross multiply. I get 2 minus y is equal to 3xy minus 4x. Everybody okay with that step? Anybody remember what we do at this point? I got to solve for y. Let's add a y. You could subtract the 2, but let's add y to both sides. And then let's also add a 4x to both sides. Is that okay? So as I've done that, I have 2 plus 4x equals 3xy plus y. So what I've done is I've gathered all of my y's on one side and everything that doesn't have a y on the other side. Remember what you do now? Factor out the y. Now I've isolated y. What's my last step? Divide by 3x plus 1. Very good. And if you divide by 3x plus 1, you get f inverse of x. Not derivative. Wrong class. F inverse of x is equal to 2 plus 4x over 3x plus 1. Question? Anybody? Got it? Okay. Flip it over. 2 examples left. F of x is 2 minus 3x to the third. I could write this as x equals 2 minus 3y to the third. Now I want to, again, solve for y. What do you do first? Subtract the 2. Divide by negative 3. X minus 2 over negative 3 is equal to y to the third. That's my last step. Cube root. And so you get f inverse of x is equal to the cubed root of x minus 2 over negative 3. Now here's the deal, you guys. Sometimes these don't work out this easily. Okay? I'll show you. Take out your calculator. I'm going to type in 2 minus 3x cubed And I'm going to type in the cubed root. So I got to go math on number 4 is cubed root. Double parenthesis x minus 2. Parenthesis divide by -3. Parenthesis. And I'll graph the line y equals x. Everybody got it? Well, I'll wait till you got it because I really want everybody to see this. Okay, so I press graph. Whoop. Okay, I'm going to pause it. Okay, you can press enter to pause your calculator in case you didn't know that. Does that pass the vertical line test? Of course it does. It's a function I plugged in my calculator. Does it pass the horizontal line test? Yes. Because your original function also passes the horizontal line test, its inverse, okay, is probably going to show up and be all right. Now, let's watch. So I can press enter to undo it. Okay, the inverse. Does the inverse pass the horizontal line test? And the vertical line test? Okay. So because the function is 1-to-1, I'm not really going to have any problems. Now, as you look at the line y equals x, does it look like the one is reflected over the other? But if you graph one of these and they don't pass the horizontal line test, then you got a problem. Okay? Then you have a problem. Watch. You'll see what I mean on the very last problem. We have 4 plus square root of x plus 1. I switch the values. And that's going to give me x equals 4 plus square root of y plus 1. What to do, what to do, what to do. Subtract 4. Now what? Square both sides. How do I square both sides? X minus 4 squared is just x squared plus 16. Yes? No. Gotta, right, multiply it all out, FOIL it out. I get x squared minus 8x plus 16 equals y plus 1. Subtract your 1. X squared minus 8x plus 16. I'm sorry, I subtracted the 1, so I got 15. Is equal to y, or your inverse of x. Inverse of the function. No, I'll be fine. Okay, now if we graph these, type this into my calculator, and if you don't want to type it in, that's fine, but make sure you're watching up here. I got 4 plus the square root of x plus 1, and then I have x squared minus 8x plus 15. Okay? I'm going to take that off. Now watch. Okay, does that pass the horizontal line test and the vertical line test? Yes. Does that pass the horizontal line test and the vertical line test? No. Think about it, you guys. If we took this radical function and flipped it over the line y equals x, this is the only portion that we should get, right? I mean, if we took that line, and I go, y equals x right here, and I flip that over, this point ends up over here. This point ends up over here. This is over here. This is over here. This is over here. This is over here. So on and so forth. I generated this whole back side. I can't have that, can I? I can't have that. So therefore, we have to do what we call restrict the domain. Restrict the domain. We can't come up with this back side right here. Okay, we can't come up with it. So you tell me, what is that coordinate right there? Where does it start? Where does this coordinate start? -1, +4. So if the inverse, switches the x and the y, what is going to be the coordinate where this thing should start? 4, -1. Look at your graph. Does it look like that starts at 4, -1? You're darn right it does. So therefore, I have to restrict this. I have to say only for x values that are in 4 to infinity. So I found the inverse. But the inverse doesn't work for all real numbers. The inverse only works for those numbers. Again, we can't include the back side of the graph. That's illegal. Okay? That's not an easy thing to think through. You're going to have to come to those problems on your assignment, see if you can get them. If you can't, we're going to have to talk about them again. All right? The other should be a piece of cake. 2.9, page 236. 1 through 6 is simply looking at a graph and deciding whether or not it passes the horizontal line test. Those are easy peasy. 17 through 20 are problems like f inverse of 8. What is it? What input gives you an output of 8? Those should be pretty easy. 33 through 47 odd. You're going to be switching x and y values and coming up with inverses. Tomorrow we'll go over the last 4 problems as well as a couple on your other assignment, and we'll go from there. Wednesday, a complete work day. I'm a super nice guy, despite what Tara posted about me on Facebook. I do. I'm super popular. I got like 5,000 friends. All made up? Wow. That was a slam. Okay, so what was the question? You don't have to write this down. I'm just telling you kind of what you're supposed to do during those problems. Okay? But my guess is in these 7 minutes, you could very possibly get through 1 through 6 and 17 through 20. On your mark, get set, go!